Hi all, in this video we are going to see the demo of data visualization using Tableau. So before get into the hands-on demo, we will just have a basic information about a Tableau. So Tableau is a powerful data visualization and business intelligence tool which will help the user to analyze and visualize the data in an interactive way which can be used in different industrial applications. And this is one of the use case where we can use the Tableau visualization. I have chosen a use case environment as a healthcare analyst. So here we need to improve the hospital performance and the patient care. So for example, the hospital wants to analyze all the patients, so who are all the inpatient and the outpatient, and in order to improve the efficiency and the reduce wait times, and they want to give a enhanced patient care by maintaining the electronic health records. So by using Tableau, we can visualize the key matrices about the records of the patients and staff schedules and the resource allocation. So this will help the hospital management in order to get a real-time data insight so that the doctors and the administrators can have a analytics, and based on that they can make a quick decisions. And also it will use for the predictive analytics. So based on the historical data maintained in the electronic health records, they can easily identify the risk and the trends, and will improve the patient outcomes. That is, it will help in the early detection and the better resource planning, that is appointment and scheduling of the doctors and the resources that can be improved by using this data analytic tool. And interoperability, we can integrate the data sources which is coming from multiple sources, either from the HR, IoT devices and the lab reports. And these are some of the features we will get for the Tableau, which is used for the data visualization. We can have a easy drag and drop interface, so that can be accessible for both technical and the non-technical users. And without writing any complex code itself, we can create different types of visualization. And there are wide range of visualizations are supported inside the Tableau. And the data connectivity, we can connect the data resources which is from either a CSV file, Excel, or the servers or the cloud-based, web-based data also can be integrated easily inside the Tableau environment. And real-time data analytics, so we can analyze and visualize the real-time data, which will enable you to make some insights derived from the data, and also it is used for the decision making. Interactive dashboards, the user can create the interactive dashboards with filters, parameters and the actions. And data blending, so we can blend or we can integrate the data from multiple resources into a single visualization. And advanced analytics, we can do predictive analysis, trend analysis, forecasting, clustering. So different applications we can use for the analytics. Then custom calculation and scripting, it will allow the user to create some custom calculation by using some formula languages, and mainly it is also used to integrate the applications of the AI, machine learning and the NLP. So this is the thing how the informations will be maintained in the Tableau. Tableau will act like or it uses a workbook which is like a Microsoft Excel, and this workbook contains sheets. The sheet can be either a worksheet, or it can be a dashboard, or it can be a storyboard. So worksheets means wherever you can build your views by dragging and dropping the fields into the shelves of the worksheets. And dashboard, which is a combination of multiple worksheets in order to create a single view which can be derived from the multiple worksheets. And story, which is a sequence of views and the dashboard which will work together to convey some information. And there are some fields which will be help you to create the manual calculated values. So in order to do that, we have something called as calculated fields and the parameters. And before going into that, the data in the Tableau will be, or in the data sheet will be maintained as a data fields. So the data fields are come from the columns which is available from our data source, and basically the data can be either a qualitative value or the quantitative value. So the qualitative values will be represented as dimensions, and the quantitative values will be as a numerical value which have the representation as a measures in the Tableau. And what is meant by calculated values? So calculated values are, or calculated fields are used to create a new data fields in the data source in the worksheet for the better analysis. So here you can see you can write some custom codes in order to define a criteria. Based on the criteria you want to display which are the values are above threshold or below threshold, and based on the sum or the average you can write the custom codes inside the Tableau. And we can write R scripts and also Python script also inside the Tableau environment by using the keyword called as script. So there you can write the coding for the R programming, and also you can write the Python programming. And the parameters are the dynamic values which is used to create filters in order to provide interactive visualizations and the calculations in our worksheet. So now we will see the demo how we can integrate the outcome of some Python coding. That is, here I have used as an example as a clustering algorithm. So I have used the clustering algorithm as a k-means clustering algorithm. The outcome of the clustering algorithm I am going to integrate or project inside the Tableau for better data visualization in order to know about the features, and also I am going to do some cluster analysis. So instead of using the k-means clustering, you can use any other clustering also for your application, or you can get the outcome of the classification algorithms also you can project in the data visualization in Tableau. So to start with the demo, so I have a data set. So this is my data set, that is a iris data set. The iris data set, here I have 4 features: sepal length, sepal width, petal length and the petal width. So here it is a clustering algorithm. It is an unsupervised algorithm. So I am not having any target label. So generally you know that the iris is a flower which having 3 different categories, and based on these 4 features the 3 categories will be divided. So I am going to use with the number of cluster is 3 to group these flowers into a category of 3 different flower category, which are all type Setosa, versicolor and the Virginica. And here I am not having a target column, so I am having only the features to work in it. So totally I have 150 data. So this is my data set. So this is the environment, the Jupyter environment. I am going to implement the k-means clustering algorithm so that I will identify the cluster label for the each and every data point. Now we will see the demo how we can use that input CSV file in order to do the clustering operation. So since you know the 4 features, so based on the 4 feature, the clustering algorithm I am going to use k-means for dividing the data points into 3 different clusters based on the features. So to start with, first that CSV file to be loaded inside the Jupyter environment. So I am going here and then I am going to upload the iris file. I got upload. So once it is uploaded, so I am just reading the file. After reading the file, there may be some, there are some null values are there, so I have used the mean imputation for removing that null values with the corresponding mean values. And after that the data will be having the input features are divided in the X variable and followed by the datas are standardized in order to improve the efficiency of the algorithm. All the values get normalized, and below that we are using the k-means clustering algorithm. The k-means clustering algorithm is available in the scikit-learn library, where we have to give the number of clusters. That is, here I have given the number of clusters 3, and the random state specified the random cluster centroids will be initially taken in order to continue the operation. And now we have trained the k-means algorithm, and finally the labels whatever we got, it will be stored in a data frame. So I have created a new column called as cluster label column, and there I am storing the labels whatever I got out of the clustering algorithm, that is also appended along with the original features. So here you can see this is the cluster labels what we got through the k-means algorithm. Instead of using the k-means algorithm, we can use The other clustering algorithms such as FCM, SOM or hierarchical clustering, other clustering algorithms also you can use it and get the corresponding cluster label. And once the thing is finished, next I am going to visualize. So here you can see all the data points are divided into 3 clusters. So based on the number of clusters we have specified in the k-means clustering algorithm. And once the data are available in the data frame, I am writing that entire data inside the CSV file called as clustered_data.csv file. So this file only I am going to import inside the Tableau environment in order to do the feature analysis and the cluster analysis. So to have that file, so I am going to download the file from the Python environment, that is the Jupyter environment. So this is my file, and this file I am going to download it. So now this file is also available in my download. So now I am moving to the Tableau environment. So this is the Tableau environment where I have to start a new workbook. So I have clicked a new workbook. So this is my new workbook. So first I have to connect the data. So here it's an option, connect your data. Now we are connecting with the CSV file. So select the option is text file. So once the text file is selected, it will ask which file you want to load it for the analysis. The CSV file I am loading is a cluster.csv file. So as you see here, once the file is loaded, the input whatever we got it is available here, the 4 features and along with the cluster label. So the cluster label, I want to make it as a categorical variable. So I am making it to be changed as a categorical variable. So here you can see here, you can click it and change it to a string variable. So it can become a categorical variable, cluster 0, cluster 1 and cluster 2. So now here this is the dashboard. Here you have your data source and followed by your worksheets. And if I want to add more worksheets, I can click here new worksheet. If I want to add a dashboard, I can use a dashboard. And if I want to create a storyboard, you can click a storyboard. So first I will go with the worksheet. So this is my first worksheet. So here we have basic options. So here we can have different visualization tools are available here. Each and every data visualization, it will ask how many dimensions you need, how many measures you need. So here dimension represents the categorical values and the measures represents the numerical value. So I will show you what are the things you can do with the numerical values, what are the things you can do with the categorical value. So here you can see the information from our data will be loaded here. And you know that our features are the numerical and the cluster label is a categorical. So I am just drag and drop this numerical value. So when I use numerical value, I can use measures. So what are the measures you can use it? The measures can be any aggregate function as sum, average, median, count, minimum, maximum, percentile, standard deviation, variance, all the things you can do with the numerical values as a measures. So suppose you are dragging and dropping a categorical value. So when I use a categorical value, I can have an option such as we have the dimension. So the dimensions we have the measures only as minimum, maximum and the count. So this is the way how you can know what are the properties you can have it for the numerical values and the categorical values. So now I have created or I have used the petal length as one of the input. So here I am going to have the average of all the petal length and the for each category. So I am going to have an average. So like this you can have any numerical values, you can have a different type of aggregate function you can apply and plot it in a graph. So this is a simple bar graph. So now I am going to use how to create So now I am going to show you how to create parameters and how to create a calculated field. So I am adding a new worksheet. So in this new worksheet, I am going to add one parameter. So what I am going to do is, so I am going to create a threshold value. So for a particular feature field, and if any value above the threshold, I will display in one color. The value below the threshold, I will display in another color. So to start with, first I will upload one feature in the column. So this feature I have uploaded. The feature I am needed data points. So in order to display as a data points, I am using as a dimension. So I got this. So now what I am going to do is I am going to define a threshold value. So for that we are using a create parameter. So in the create parameter, I have to give a name for the parameter. I am going to define a threshold value for this petal length. So from this itself, I can able to know it. The minimum value is some 1 and the maximum value go to up to 7 for the petal length. So the data type is float and the current threshold value I am going to give as 3.5 and the range I am going to give, the minimum range is 1 and the maximum range is 7. So I have created a threshold value. So now I am going to make this petal length data points to be visible in a row wise instead of column. So I have just move it to row, so it will be applied in the row wise. If it doesn't need the label values, just remove the label values. So the data points are plotted in a Gantt chart. So now I am going to write a script so that the data points whichever having less than 3.5 will be having a below value, below average, and whichever is above 3.5 I am going to give this is a above value. So instead of doing that, we have to create a calculated field. There only we are allowed to write a script. So I am going to write a PL function. So this function I am going to write a function. So you can write like a if else concept. So I am going to consider if my petal length centimeter is greater than my petal length threshold, then I am going to display it is above 3.5, else I am going to write it is below 3.5. Then you end with end. So like that you can write the custom codings so that to provide some filter in your visualization, you can apply this custom coding. Instead of using this, you can use Python or R programming. By including a script, you can include the R programming and Python programming. So when I apply and click OK, so the functionality get updated. So now what I am going to do is I want to view the threshold. So just give show parameter. The parameter will be showed here. Now I am adjusting this threshold, the color value need to be changed in my feature. So I am applying this function to the color. So you see here all the value below 3.5 now changed to an orange color, which specify the values are below, and whichever above 3.5 it is giving the value above. So now I can dynamically change my threshold value. So here the output also changed according to that dynamic visualization. So the next thing what we are going to do is I am going to create a bar chart. So to create a bar plot, we need the row wise the feature and the column wise the count. So we are going to take one of the feature, that is I am going to keep it as a petal. So I don't want it as a sum, it is an average I need. So I am going to keep it as, instead of the measure, I am going to keep it as an average. And the column, so that particular feature, class wise, what is the average, I want to know it. So this cluster, I am going to keep it in the column. So now you can see in class wise, the features average of the petal length is given. So as you see here, for the 0th class, the average petal length is 5.5, and for this 1.4, for this 4.3. So here itself we are having a clear discrimination of the average petal length to differentiate 3 different clusters. So now we want to give a color for it. So if I want to give a color, I can just put the color. So you can have the 3 different clusters will be given with 3 different colors. So if I want to remove it, you just click it and delete. So the color value get removed. Okay. So now what we are going to do is the same parameter and the create field, I am going to apply for this bar plot in order to change the color. When the average goes beyond some value, the bar plot will in one color, and whichever value going above the average, the bar plot will be in another color. So I am going to define another one, create calculate field. So here I am going to put the average. So previously, based on the data point value, you have adjusted the color. So now I am going to apply the threshold based on the average value of the each class cluster. So now the coding you have to write is average. So average of petal length, which is greater than the threshold already I defined. Okay, then that is below, and else that is above, then end. So this I am apply and click OK. So it gets saved. So I want to view the threshold parameter. So show parameter, the parameter will be showed here. So some values. So now this function, whatever we define now, that is the PL average function. So that I am going to put it in the color. So now you see the values of the each class average, which is less than 2.5, which will be in one color that represents below and the above. So I have written the condition in a different way. So if I want to edit it, so just right click and then you can have edit. So here I have a threshold value which is less will be below and which is above will be above. So now I can change it. I can go above 4.5. So now less than 4.5 will be as a below color and this will be in the above color. So now we are going to explore the different data visualizations in order to do with the feature analysis. So I am just clicking the show me. It will list you all the different visualizations available here. I am going to create another one sheet. So first I am going to create a histogram. So now I want to display histogram for knowing the feature distribution. So the feature will be put in the column. So here I want to apply histogram. So select the histogram. So now the histogram is available. So you know that for each feature, each value of the petal length, how many count is available out of the 150 data points. Okay, so now I want to give a color value for the different ranges of class. So the cluster you have to put it in the label. The cluster will be, the label value will be put it in the color. So you can see here the distribution. So it will clearly discriminate you, that is the cluster 1 having generally the petal length value of minimum of 1 to maximum of 2. But for the cluster 2, the petal length minimum should be 3, maximum should be 6. And for the cluster 0, the petal length is minimum of 4 to maximum of 7. So there may be some overlapping with the class 0 and the class 2 petal length. So this will clearly discriminate you the variation of the feature distribution to distinguish the different cluster data points. And the next thing we are going to see is a bar plot. So here if I want to give a name for the sheet, you can just right click, you can give a rename. So here this is a histogram. And now I am going to create a bar plot. So this is the thing, I am going to create a bar plot. So what I have to do is, so the label I have to put it in the column. The label means your cluster category. So this I am going to put it in the column, and any one of the feature I will take it and that I have to put it in the row. And here it is a sum of all the features. So I don't want that sum. I will keep the measure as the average. So this will help you the average value of the feature in each cluster. So if I want to give a color to different class, then the cluster will be drag and drop and put it in the color. So each cluster will be given with different colors. So here I am going to give a name as bar plot. Okay. So next plot I am going to use with the box plot. So now I am going to create a box plot. So to work with box plot, first the cluster label I am putting in the column, and then I am taking any one of the feature. The feature I am going to keep as a row wise, and there I am going to use with the bar plot, and this I want to display the data points. The data points will be displayed as a dimension. So here you see here, and the cluster 1 we have the petal length values in the range of 1.7, and then when it moved to the value of petal length 3, it moved to the cluster 2, and here it is a overlapping between cluster 2 and the cluster 0, what we have seen in the histogram 2. And if the cluster or the petal length is going to the value above 5, and this belongs to the cluster 0. And the next plot we are going to see is the comparative bar plot. So here you want to rename it. So I am going to give it is a box plot. So I am going to create a next sheet. Here I am going to use with the comparative bar plot. So how will you use the comparative bar plot? I want to use all the 4 features in the row wise, and the column I want to keep the label based on the category. So I drag and drop all the features. So the first feature I will just change to average. Every feature you keep it as average, and the second feature petal width, the average, and then sepal length, which is average, and then sepal width, that is also again an average. And then we are keeping the cluster label in the column, and I am going to use with the comparative bar chart. And now you can see the different clusters and along with the 4 features available. So this will help you to make a comparative analysis. The sepal length will be generally high value as compared for the cluster 0 when compared with cluster 1 and 2. And here the petal width will be less for cluster 1 as compared with the cluster 0 and cluster 2. So this will help you a feature discrimination to do an analysis which features support best for which cluster. So this will be, I am going to keep it as it is a comparative bar chart. Okay, so now I am going to create a dashboard. So the dashboard, as you know, it is used to combine multiple views from the different worksheets that can be projected inside the dashboard. So if you want to increase the size of the dashboard, you can increase the width of the dashboard. So what I am going to do now, I am going to keep that comparative threshold I have made. So that 2 things I am going to keep it here first. So what I am going to do here, I am going to drag and drop the threshold 2 values I defined for the features. So this I want to reduce with the size. So reduce the size, and also I am going to keep the sheet 3. So 2 sheets I am keeping, which I am going to change based on the threshold. So now you can see how dynamically when you change a value, both the visualization get updated. So I am going to keep a value which is less than 1.5. So whichever value clusters having less than 1.5 for the petal length, that value given with the below value. So when it reach around greater than 4.5, so now these 2 clusters having a change color, and the data points of that particular thing also change its color. So this will help you to have a multiple views that can be projected in a single dashboard. You can control with a single filter value. You can know what is the variations or analytics changing when you change the threshold value that is affected in the data point and in the cluster analysis. So similarly, I am going to create a next dashboard. So this also I am going to change the size to the maximum size. So I am going to keep the comparative bar chart here, and before that I want to create a scatter plot which will help you to do the cluster analysis. So I am going to create another one sheet. There I am going to do a scatter plot to do the cluster analysis. So to do a cluster analysis, you need to plot any two feature in the x and y axis. So I am going to take one feature in the x axis. So that I am going to give us a dimension. And similarly, I am going to keep another one feature in the row wise. And that also I am going to give a dimension. And this will help you to have a scatter plot. The x-axis is a petal length and the y-axis is the sepal length. So now you want to give a cluster color as we displayed in the scikit-learn with the matplotlib or the Seaborn, the scatter plot with the cluster analysis. So now the cluster will be taken into a color. So 3 different clusters will be displayed in 3 different colors. Suppose you want to change the color for the user defined color, go to edit color, and the cluster 0 I want to change the color to green color. Select the green color and apply. Okay. Suppose you want to change this orange color, so click it, edit color, and orange I want to change to blue color, so click apply. So now we have made a scatter plot. So I am going to give the name of this worksheet as a scatter plot. So these two I am going to combine inside this dashboard. So already I have a comparative bar chart which represent for every cluster, and along with I am going to make this scatter plot also, keep it inside the same dashboard. So now I want to know about a particular data point inside the scatter plot. So what is the particular feature effect for that? The data point belong to that particular cluster. I want to know it. So you can apply filter here. So you can select the filter, choose any one data point in the cluster 2. So immediately you can see in this comparative bar chart, the features which are related to that particular data point in cluster 2 will be highlighted. Suppose you are changing a data point to the cluster 0. So the features which are contributing to the cluster 0 for that particular data point get highlighted. And you select a data point in cluster 1. So this get highlighted. So that only help you to make a dynamic decision making whenever you apply some filter, how the values get varied, you can easily identify. If I want to remove the filter, click the filter. The same thing in the comparative bar, I can just click a filter. I want to know about only the cluster 1. So I just click a bar chart in the cluster 1. The data point belong to cluster 1 get highlighted. And cluster 0, so cluster 0 data point get highlighted. I hope you got some basic idea how to do data visualization using Tableau from the data source of CSV file in order to do the feature analysis and the cluster analysis. Thank you.